In the previous video, interfaces were introduced. By now you should have a good idea of what an interface is and why you would want to implement them into your code. In this video, we will cover the finer details of interface conventions. To begin, looking back at the interface example project from the previous video, I'll point out that all the methods that were declared in both the feed and REST interfaces were abstract methods. To quickly review, this means that the methods were declared without a body. In other words, only the method signatures are included within the interface. While abstract methods are the only methods included in these interfaces, they are not the only methods that an interface can contain. Interfaces can also contain default and/or static methods. In providing an example of default and static methods, I'll first pose a question. What happens if a programmer decides to add additional methods to an interface after other programmers have already implemented the same interface into one or more of their classes? For example, assume a programmer has implemented the REST interface within a class being used in software that has already been released, and one day the author of the REST interface decides it would be a good idea to include another abstract method within the interface. For now, let's assume this method is called nap. While looking at a class that has implemented the REST interface, such as the dog class, we can see that the class is now broken. And if we try to run the program after the new method was added to the REST interface, we are unable to as the program now throws an error. While it may be hard to see with such a simple example as this one, in the real world something like this can lead to huge trouble for all parties involved. However, changing the contents of an interface doesn't have to be catastrophic, and it shouldn't be, as changes are sometimes necessary in order for improvements to occur. Now there are a couple ways we can make necessary changes to an interface without causing code to break. And the first way this can be done is by using default and/or static methods. First, let's look at how this can be done using default methods. Looking at the Java docs, default methods enable you to add new functionality to the interfaces of your libraries and ensure binary compatibility with code written for older versions of those interfaces. What does this mean? Well, if we go back to the REST interface and add the modifier default to the front of the nap method signature, notice all errors go away in the dog class, but we get an error on the nap method signature. That is because now that the default modifier was added, this is no longer considered an abstract method, and therefore we must provide a body to the nap method. So we will replace the semicolon with braces and add a printline statement that simply says napping. And since the default method is defined within the interface, there is no need to define it in any class that implements the REST interface. In fact, we can go right over to the animal farm class and invoke the nap method on both the first pet dog object and the second pet bird object without any errors. However, notice the nap method simply prints napping to the console. It does not print dog is napping or bird is napping as the other methods do. This is exactly what we designed the default method to do within the REST interface. In other words, by default, the nap method was designed to simply print napping. If we wanted to, we could redefine the nap method in the class that implements the REST interface like such, so that the nap method acts in the same manner as the other abstract methods from the implemented interfaces. In this case, we'll redefine it to print dog is napping to the console. And when we do so, notice dog is napping is indeed printed to the console when the nap method is invoked from the dog class. However, when the nap method is invoked from the bird class, we still get the default message of napping printed to the console. As you can see, choosing to add the nap method to the REST interface as a default method prevented any code from being broken and allowed the flexibility to modify the new method to be more in line with the ones that had been there only if we absolutely wanted to. Now considering static methods, we can change the nap method to a static method by replacing the default modifier with the static keyword. When we do so, while we do not get any errors in the REST interface, notice we have a new error in the animal farm class. That error appears where the nap method is invoked on the bird class. Notice there is no error where nap was invoked with the dog class because we redefined the nap method in the dog class. If we go into the dog class and remove the nap method definition, we get an error on both invocations. That is because we changed the nap method to a static method, and by definition, static methods are associated with the class rather than with any object. Right now, nap is being invoked through the dog and bird objects. In order to get rid of the error, we need to instead invoke it through the REST interface, like such. Another thing to point out is that if we go back into the dog class and re-implement the nap method, then run the program again, notice only napping is printed to the console, not dog is napping. That is because static methods cannot be overridden like default methods can. In utilizing static methods, programmers would regard them as utility methods, not as essential core methods. Therefore, while default and static methods can both be utilized in an interface, In addition to abstract methods, each has their purpose, and deciding which to use should be well thought out. The other way we can make necessary changes to an interface without causing code to break is by creating a new interface that extends the original interface. For example, we can create a new interface called REST Plus. The REST Plus interface can include all the contents of the REST interface by adding extends REST after the interface name, REST Plus, like such. And in the REST Plus interface, we will add the abstract method nap. Now let's go into the bird class, and instead of implementing the REST interface, we will implement the REST Plus interface. Notice we get a red line under the class name bird, and when we hover over, we get the message, the type bird must implement the inherited abstract method restplus.nap. Let's go ahead and select the first fix to implement the nap method. The body of the nap method will be similar to the bodies of the already implemented methods. It will simply print bird is napping. In modifying the dog class, we'll remove the nap method. Finally, within the animal farm class, we will remove the invocation of the nap method for the dog object named firstPet, and we will invoke the nap method through the bird object named secondPet. Now we can run the program with no errors. The important thing to note here is that we successfully added a new interface called REST Plus that extends the REST interface. In doing so, a programmer can decide to maintain the original functionality of the REST interface without changing anything, as the dog class is currently doing, or a programmer can decide to implement the newly added functionality by implementing the new REST Plus interface that extends the functionality of the REST interface, as the bird class was modified to do. In either case, the code is never broken once the additional interface functionality is incorporated. In other words, by creating a new interface that extends the original interface, the classes that implement the original interface will not break, and the choice to implement the newly added functionality is left to whoever maintains that code, instead of forcing an implementation that will break code. So far, we have focused on the various types of methods an interface can contain. In addition to methods, an interface can also contain variables. All variables declared within an interface are by default constant, public, static, and final. Let's look at an example of using a variable in an interface. In the feed class, let's create a string variable that we will call detail. Notice that the variable name is in all caps, as this is the normal convention for constant variables. This variable will be initialized to contain the string. The feed interface contains two abstract methods, eat and drink. Note that the value of this string is unable to be modified since it is a constant and final variable. If we do go to the animal farm class, we can utilize it through the feed interface since it is a static variable. We will do so by using a printline statement to print it to the console. When we run the program, we can see the value stored in the variable prints to the console as expected. If we try to assign a new value to the variable, notice we get an error that reads, the final field feed.detail cannot be assigned. The last thing we are going to cover regarding interfaces is the ability to use interface names anywhere a data type name is used. For example, let's get rid of all the invocations of the interface methods within the animal farm class. Let's also get rid of the printline statement with the string variable detail. Now let's declare a new variable of the feed interface type called obj. Next, we'll initialize the feed variable to the dog object firstPet. Last, we will invoke a method from the feed interface through the feed variable obj. In this case, we will invoke the drink method. When we run the program, we see dog is drinking is printed to the console. As you may have guessed, we can change firstPet to secondPet and run the program, and now we see bird is drinking is printed to the console.